Assalamualaikum warahmatullahi wabarakatuh. My name is Haziq Bin Sazmi, and today we are going to present about Lab 1, which is Introduction to High Voltage Lab in FTKEE. Our group members, which is as for myself, Haziq Bin Sazmi. Second is Syuhada, and last Muhammad Haziq. And our lecturer is TS Dr. Zikri Abadi Baharudin. So I'm going to present about trace power cable circuit, starting from isolated switch to the power block terminal, and then distributed to the controlling circuit system, and also internal transformer of the frequency converter. Today we are going to use the kit 4.0 high voltage construction kit, which is the latest technology from Heavily Hypotronics, Switzerland. As for the high voltage construction diagram, you can see that from the power isolator, and then we from power isolator we connected to power terminal block. Then power terminal block we connected to internal transformer, followed by controlling circuit system, and last we connected to output block. So when the three-phase supply is activated, the three-phase power supply will generate through the power terminal block. The power terminal block is connected to the controlling circuit system and the internal transformer. The three-phase supply will generate through the output power terminal and provide power supply to the controlling system and the internal transformer. Next is the function of the controlling system, which is the brain of the high voltage, which contain electronics component. The interior transformer will convert the three-phase supply to acceptable voltage of the system. And lastly, is the output of the internal transformer within the frequency converter are connected to the output block. Last, the output internal transformer will connected to the output block. For the next slide, which is contains schematic diagram of the frequency converter. As we can see that in this schematic diagram contain 5 cores of the power cable. Also, the schematic diagram frequency shows that using 50-60 Hz frequency of the three-phase supplies. Okay, for the next slide, I will pass to my other members.
Assalamualaikum warahmatullahi wabarakatuh. Today I will explain to you two tracing tasks, which is trace lamp and alarm circuit and trace interlock system. For the first task, which is trace lamp and alarm circuit, there are two types of lamp and alarm circuit port that connected to the frequency converter, which is hashtag lamp plus on and lamp plus on potential free. Hashtag lamp plus on is connected for frequency converter safety. As for lamp plus on potential free is connected to the testing cage, or we can call as testing room or cell cage surrounding frequency converter for environment safety. As you can see in connection of lamp plus on potential free, there are 4 pins are used, which is pin 7, 8, 9 and 10. Pin 7 is the common of the potential free contacts. Pin 8 is the switch potential free contact for the lamp. Pin 9 is the switch potential free contacts for the green lamp, and pin 10 is the switch potential phase contact for the horn. Both types of lamp and alarm circuit is used auxiliary cable to connect it to the frequency converter. For the second tracing task, which is trace interlock system, as we can see in the connection of interlock system, the interlock is used to monitor the door to the high voltage portion of the device and to monitor whether the high voltage is removed from the ground rod. It can also be a door mounted around the high voltage part in a safety fence. The ship hunting plug with 6 pins can be used for attaching the interlock. They usually use two close contacts together. The interlock operates with a dual channel service, so it tracks the time of divergence between the two contacts and has a cross short detection to avoid linking the two circuits in a fault cause together. For interlock connection, shaded cable needs to be used. The cable shell must continue through the connectors. The end of the safety circuit is a termination or a bridge. I recommend you to use safety fence or similar to it for your own safety. That's all for me. Thank you.
Assalamualaikum and good afternoon. Today I will explain a bit about the one of the most important section in the frequency converter. My part is I get the press emergency button. Emergency button is one of the most important section in the frequency converter. This is because emergency stop is a device that will be activated if there is any emergency happen. When emergency happens such as fire or shock, the frequency converter setup of function is activated when emergency button is been turned on, and then the frequency converter will be halt after receiving the command. The emergency stop works with a dual channel operation which will monitor the dispersion time between the two normally close contact, and it also has a short detection to prevent the connecting the two circuits together in a fault case. After that, I will explain a bit about the implementation when using emergency button. When we using emergency button, the cable in the circuit must be used. The type of the cable is used is shaded cables, and then the plug has to be bridged if the second emergency stop is not being used. And lastly, at least one emergency stop is connected. The last one in the one of the most important section in the frequency converter is a trace grounding system. I will explain a bit about the trace grounding system. Grounding system is a backup pathway that has an alternate route for an electrical current to flow to ground due to any risk in the electrical current such as fire and overcurrent. A grounded connection includes a connection between the electrical equipment and a ground through a wire. The ground switch is switched to grounded position when surface status is HV off and always ungrounded when the surface status is HV ready. And then I will talk about the implementation during grounding system. There is some precaution step or that you need to be careful about grounding system. Firstly, if the grounding system is in grounded position, the live parts can be under voltage. The second one, the high voltage parts of the system should be double checked to ensure it has been grounded correctly after switching off. The third one, I will explain about the cable that are suitable to be used in the grounding system. Firstly is there are two types of cable, which is the first one is the power cable with concentric neutral conductor, and the second one is power cable with tap shield. For the first one, the power cable with the concentric neutral conductor, it is suitable to be used for utility power distribution application, while the power cable with tap shield is usually suitable for industrial power distribution application or small runs inside the substation. Thank you.